Let's take a look at this scenario that we have a linear and a quadratic factors. Linear and quadratic factors in the denominator. Okay, perfect. So give us an example. In this example, I ask you to write this fraction using partial fractions. Here I have 3 times x squared plus 4x plus 4, and I divide this guy up by x cubed plus 4x. Very well. So remember, our very first step is to factor out the denominator. You're going to copy whatever is on your numerator, 3x squared plus 4x plus 4, and on your denominator, you're factoring out x, you end up with x squared plus 4. So as you can see, you have a linear factor and a quadratic factor. So in this example, your linear factor is x and your quadratic factor is x squared plus 4. So what is the scenario here? What should I do? How do I decompose this into partial fractions? First of all, when you have one linear factor and a quadratic factor, you end up with 2 fractions. So quickly write 2 fractions. Your very first fraction has linear term x on its denominator. Your second fraction has the quadratic expression. You cannot factor out this quadratic expression. Guys, x squared plus 4 is not x plus 2 times x minus 2. X plus 2 times x minus 2 is x squared minus 4. These two are different from each other. Here you have x squared plus 4, which is not x plus 2 times x minus 2. This is a mistake. X plus 2 times x minus 2 is x squared minus 4. So we cannot factor out x squared plus 4. X squared plus 4 is not factorable. You can use complex numbers, but here our goal is not to work with complex numbers. You only need the real values. So x squared plus 4 is not factorable. So again, we have 2 fractions. The very first fraction has the linear term on its denominator. The second fraction has this quadratic expression, which is not factorable. So just copy this guy down here. Now for its numerator. Guys, this is important. Please pay attention. Here you have a linear expression on the denominator. Your numerator is going to be a constant, 1 degree less than the denominator. Here you have a quadratic expression. 1 degree less than a quadratic expression is a linear expression. So here you're going to have bx plus c. Bx plus c. A is a constant on a linear expression plus a linear expression on the quadratic expression. Very well. So far, so good. So far, we identified the factor form of the denominator. We know that we have a linear expression and a non-factorable quadratic expression. So we get 2 fractions. The first fraction has a linear expression on its denominator. The second fraction has this non-factorable quadratic expression. Now, as for the numerator, a is a constant, 1 degree less than the linear expression, which is a. For the second fraction on the denominator, you have a quadratic expression. 1 degree less than a quadratic expression is going to be a line, a linear expression. Now take the common denominator between these two. Common denominator least common denominator is x times x squared plus 4. Very good. So we're going to multiply the first fraction, a times x squared plus 4 divided by x times x squared plus 4 plus, and the second fraction, the denominator doesn't have x, so we're going to multiply both the numerator and the denominator by x. So we get bx plus c, and don't forget to put it in a parenthesis set, bx plus c times x divided by x squared plus 4 in the parentheses times x. Very well. So now that you have the same denominator, it's going to be one denominator, and you're going to copy down the numerator, a times x squared plus 4 plus parenthesis bx plus c, bx plus c, close the parenthesis, multiplied by x. This guy is equal to the original fraction that you try to write it in factor form using partial fractions. So copy this guy down, 3x squared plus 4x plus 4 divided by x cubed plus 4x. These two denominators are the same. We set the numerator equal to each other. So 3x squared plus 4x plus 4 must be a times x squared plus 4 plus parenthesis bx plus c times x. There we go. So let us distribute a into parentheses, x into parentheses, and do whatever we did before, setting up a system. 3x squared plus 4x plus 4 equals to ax squared plus 4a plus bx squared plus cx. So ax squared plus 4a, bx squared plus cx. Cool. Very good. Now let us begin. Left hand side you have 3x squared, right hand side you have ax squared plus bx squared. Okay, so 3x squared is ax squared plus bx squared. Ax squared plus bx squared. What's the meaning of that? Well, it means that the coefficients must be equal to each other. It means that 3 must be a plus b. A plus b. And then here we have this guy here. For x, on the right hand side, you have cx. So what's the meaning of that? It means that 4x is equal to cx. Hey, I have an easy identification here. Well, it says for the coefficient of x is equal to coefficient of x, which is just c. Hey, I found c. Nice and easy. C is 4. C is 4. Very well. Okay, what else do I have? Let me see. Now, I have a constant 4, and I have 4a here. Let us set these equal to each other. It says 4 is equal to 4a. Okay. If I divide both sides by 4, a becomes 1. Very well, I found a. A is 1 as well. Nice. It was easy. It wasn't that hard. A is 1, right? Very well. So what about my b? Since I know a is 1, And also I know 3 is a plus b, a plus b. So what's the meaning of that? It means that, hey, 3 becomes 1 plus b, and b is 2. I found b as well. So the decomposition of this fraction into partial fractions is 1 over x plus 2x plus 4 divided by x squared plus 4.